will learn about introduction of CNC lathe machine chapter 1. Here we go.
What is CNC? CNC is computer numerical control, and it is set of programming numbers used in automating works or processes. A CNC lathe machine does the same operations as the conventional lathe machine. It is used to produce component with circular cross-section using turning operations and related tasks such as drilling, boring, tapping, and reaming. The main difference is the use of CNC to control the operation of the machine. Using computer programs, CNC lathe machines are able to produce components with all the advantages associated with CNC. Here we move to CNC application. CNC is to manufacture complex curved geometries in 2D or 3D was extremely expensive by mechanical means, which usually would require complex jigs to control the cutter motions. Then, machining components with repeatable accuracy and unmanned machining operations. Then, we will learn about part of CNC lathe machine. Number 1, we have frame. Frame is the base of the lathe, provides support particularly with heavy material. Number 2, we have bed. Bed provides stability for the machine and is used to start the sliding action, also can occasionally be extended or can function as a conveyor belt. Number 3, here we have chuck. Chuck responsible for holding the clamping the material that is going to be machined, and chuck can have 3 jaws self-centering or 4 jaws independent. Number 4, we have hydraulics. Hydraulics is power the main drive motor and the chuck. Number 5, we have headstock. Headstock is mounted in a fixed position. Using the chuck it rotates the material. Number 6, we have spindle. Spindle is hole through the headstock, the rotating axis of the lathe with a shaft at its heart. Number 7, we have tool turret. Tool turret is the tool carrier for the lathe, and shape and size dependent upon the number of tools mounted and or used for project. Number 8, we have cover. Cover houses the safety window and maximizes safety levels. Number 9, we have carriage. Carriage is used for mounting and moving most of the cutting tools. Number 10, we have electrical cabinet. Electrical cabinet acts as cooling center for the lathe to counter overheating. Powers foot pedals, external controls used to open or close the chuck, headstock, or tailstock. Number 11, we have monitor. Monitor houses and works with CNC control panels, which are the brains of the lathe, and machinists control the entire project from here. Lastly, we have tailstock. Tailstock is center-mounted directly opposite the headstock, used for boring, usually non-rotating. There is the advantages of CNC lathe machine. First one is easier to program. 2, easy storage of existing programs. 3, easy to change a program. 4, avoids human errors. 5, safer to operate. 6, complex geometry is produced as cheaply as simple ones, and 7, usually generates closer tolerances than manual machines. CNC lathe machine also have disadvantages. There are, first one is need adequate skills to conduct CNC operation. 2, larger investment at initial stages. 3, higher maintenance when breakdowns. Now, we moving to next topic, which is we will learn about CNC lathe turning machines coordinate system. Coordinate system in CNC lathe are important to ensure that the control system of the machine will read the specified coordinates correctly to indicate the position of the workpiece and machine tools. And there is the following points are part of this system that been shown in the figure. 1, machine 0 point is M, and 2, workpiece 0 point W. Next, we learn about axis and principle of CNC machining cutting. CNC turning machine has at least 2 controllable feed axes, marked as X and Z. When the cutting tool moves toward and backward the machine spindle, this is called movement along Z axis. When the cutting tool moves in cross direction to the longitudinal axis of the workpiece, this is called movement along X axis. Then here is #positive Z direction is when the tool moves away from the workpiece in Z axis, while positive X direction is when the tool moves away from the workpart in X axis. An easy way to understand the Cartesian coordinate system in relation to any CNC machine is using the right-hand rule. Nearly all CNC machine uses Cartesian coordinate system based on X, Y, and Z axis. Here we are learn about datum and dimensions. Has to machine a workpiece, we need a technical drawing on which we should illustrate the required dimensions to make the required shape. Has to dimension the workpiece, we need to specify a certain point on it, from which we should take the measurement. This point is the origin point. Has the origin point on the workpiece is called as workpiece 0 point W. Next topic is about two types of dimensioning. First one is absolute dimensioning. Absolute dimensioning is all measurements are taken from workpiece 0 point. Asterisk in the drawings for CNC turning absolute system considers the value of x as the diameter value, not the radius. We move to the second one is incremental dimensioning. Incremental dimensioning uses incremental values that are always measured from the current point to the next point. Asterisk in the drawings for CNC turning incremental system considers the value of x as the radius of workpiece. Lastly, here we learn about how CNC works. CNC works through numerical control and C that consist of specific codes. G codes and M codes. These are number values and coordinates. Each number or code is assigned to a particular operation, typed in manually to CAD by machine operators. G and M codes are automatically generated by the computer software.